Welcome to all to the most powerful class of the series, Part 1, Lecture 18. Very, very important. Not only this class, also further some more classes. For that matter, every class will be important. Okay, 1 minute. That is moment of a force. Okay, now one information. I will do some discussion now. Some models I will show you and explain the concept. See, there are a lot of explanations are here. All of them I am going to write in the notes. The first part of the notes is almost ready for issuing. I will announce within a week. I will announce it is ready for issuing. Therefore, those who want can, then you know the procedure. I already uploaded earlier how to get the notes. Now there, all this I will write with systematic way. Here sometimes I dictate, you should write if you are not going for the notes. But very important. I will write no doubt. Even there also, I cannot make a video notes. See, I will take some models here and show you something. That I cannot write in the board notes. I took a book and placed on my hand, then I placed a heavy object. That all I can't write. So what I will do at that time? For more understanding of this one, go through Part 1, Lecture 18 repeatedly and thoroughly and understand everything. So, go through this class repeatedly till all concepts are clear. For that matter, this is for every class. Then, I will not repeat all this again and again. I will not repeat again and again. Once I will settle, suppose sometime, I will tell it later. See, 1 minute. When you take moment, a doubt comes. Moment is about a point or axis. Sometimes people will tell, sir, last class you told some moment about axis, some chapter. Some chapter you told, sir, moment about a point. Sir, why? I will tell them. Why you have not gone through Part 1, Lecture 18? I won't tell. I will ignore the comment. They are not fit for study. When I insist so much, concepts are important and I am explaining, if they have no patience to listen all this and then later ask a doubt, I will tell not fit for education. Okay, you go through my classes the way you want, learn whatever possible for you, but complete understanding is not possible. You should have the zeal or tendency like a force later. See, force has tendency that way to learn everything and get the knowledge. Okay, now, I will not repeat all these again and again. Instead, you go through this class again and again. Instead, you go through this class again and again. Because you are learning, I am teaching. Okay, now, 1 minute. Before I start any explanation for moment, first class. See, this all I told, here some of the points I dictate. Class means, see, when I write class means what? Something I am telling in the class, those who want, actually not those who want. Those who want to learn everything should write it. A doubt comes, is it? Doubt comes, is it? Moment about a point, moment of a force is not required. Everybody knows. Moment means moment of a force, okay. Moment of a force about a point or moment of a force about an axis. Doubt comes. I will clarify that one. Okay, now what happened is, I wrote the answer here. I wanted to write in front of you. But what happened is, I recorded this a little earlier, but suddenly came to know that I had not switched on the camera. When I went there, I explained everything here. Then I went there to pause so that I can clean the board. At that time, to my shock, I saw camera was not on. Full 10 minutes talk was wasted. Some will tell, sir, you get experience. Oh, experience, yes. I get tiredness. Okay. Therefore, now I am careful. It happens occasionally. I forget to switch on the camera. Whatever I tell is wasted then. Okay. See now. Actually, earlier I wrote in front of you. So now, doubt. Moment about a point or moment about an axis. Remember, I will tell you now, the correct answer is moment basic or concept wise. The correct term is moment about axis. Which axis? Some axis. Axis, not axis. Axis. Why? It is a singular. Moment about some axis. Okay. I will clarify it now. See. Now, when a force is applied on a body, it has two tendencies. Remember, I'll show it for you now. I wrote here. The tendency of, why I use the word tendency, because when you apply a force, I told basic in the beginning of engineering mechanics, first class, force is an agent which when acts on a body either produces or tends to produce, means it need not produce. I told something for you. Imagine a fully loaded, or why fully loaded, a train parked or resting on a railway track. So many bogies are there, fully loaded. Okay, brakes are not applied. Okay, no problem. If someone will go and push the train, will the train will move? No. Why? Your force is nothing. But remember, you will not produce the change, but you have tendency to produce. Your purpose of pushing is to move it, but you are not able to do it. See, for example, one more example I will show you. 1 minute before that. Practically, or an auto rickshaw, three-wheeler, placed on a level road. It is at rest. You push it, it is on neutral gear. Push it, it will move. Why? Because your force succeeded in producing. Reason all will come later. About friction we will be knowing later. Right now, leave it. Or, see here. If I place a heavy object, it is quite heavy, because it is a whiteboard marker pen box, new one, little heavy. I will apply a force here, see. Yes, it is not moving. But still, my tendency is to move. See, no? Okay, now. I place a light object, see. See, it moved. So force, when you apply, either produces change or tends to produce the change. Same way. When a force is applied on a body, the tendency of the force is not only to move the body in some direction. See, tendency of the body to move, tendency of the force to move the body in some direction, I forgot to write here, is called translational effect. See, this is called translational effect. There is one more effect, see, rotational effect. So, second one is not, see, when a force is applied on a body, the tendency of the force is not only to move the body in some direction, called translation effect, but also, you should add one thing here, also, see, I forgot right here, it has already told, see, I told where not only means understood, but right here, but also it has tendency to rotate the body about, doubt was there, now I clarified, about some axis. I will show it now, see. These all you can't write them right there, see. If I apply a force this way, how I apply, it's my wish. See, it is moving. Only translation. There is a reason for it. I am applying a force along the longitudinal centroidal axis. Leave it now. Now see, I will hold here. I will apply a force somewhere here. See now. See now. What happened? It moved, no doubt. See. It moved. Or see here further. I will apply somewhere. See. 1 minute. See. It moved, but also what? It rotated. So there is not only linear displacement, also angular displacement. See, linear displacement is called translation, angular displacement is called rotation. So write all these things. So to rotate the body about some axis. Now, see, definition. The rotational effect of a force on a body on which it is acting is called moment of the force about some axis. Some axis. That some axis means it is called axis of rotation. About which axis it has tendency to rotate or it rotates is called axis of rotation. See, axis of rotation. And now, these all concept I told, I will clarify furthermore. I will remove all this and write fresh now to explain more concepts. Okay. Now, first come to general concept, axis of rotation. Remember, this actually comes in physics. Actually, when you study engineering, before that you studied physics. So this is actually first comes in physics, it comes in structural engineering also. Axis of rotation, see, definition. You so many times people tell it is rotating about an axis, about a point is wrong. I will tell why it is correct later. Someone will tell, just now he told wrong and correct. Wait 1 minute, wait for some time. A body is said to be rotating about an axis. That means if somebody is telling a body is rotating about an axis, he is showing an axis, see, like this. When it is correct, his axis correct if what? A body is said to be rotating about an axis if each and every point in the body remains at a constant distance from that axis throughout the rotation. See, throughout the rotation from that axis, each and every point should remain at a constant distance. That is actually radial distance. Okay. It should not change. Then that axis is called axis of rotation. Pure physics. Okay. Now, I will show you some examples. See, I will do one thing now. See, this I cannot write in the notes, nor I can write here. I will write in the notes also. Examples for axis of rotation is told in the class using his hands. Therefore, go through it, or if you want to write in your own words, go through it 4 or 5 times. It will stay in the mind. See now correctly what I am doing. Either you rotate this way or rotate this way, that is something else. Clockwise, anti-clockwise, does not matter. See, for me, this looks like clockwise. For you, this will look like anti-clockwise. That does not matter. Okay. That also some concept is there. For teasing the people or for trapping, I ask in the class. Recorded class, I can't ask. It should be either live class or offline class. I enjoy it. Okay. Or I will tell you, small joke actually. I will ask them, clockwise or anti-clockwise. Okay, joke only. People will tell from there, see, sir, anti-clockwise. I will tell, anti-clockwise, sir. Then they will think, sir, got it. Sir, for us it is anti-clockwise, but for you it is clockwise. Oh, that way. Tell me, left or right? Again they will tell, sir, for you it is left, but for us it is right. Oh, very good. Then, sir, for you it is right, but for us it is left. Oh, correct. Then I will ask them. Therefore, remember, for me clockwise, for you all will tell anti-clockwise, sir. Or if for me anti-clockwise, for you clockwise. Very good. For me right, for you left. Yes. For me right, for you, sir. For me, I told left. For you right, sir. Yes. For you, for me it is right. For you left. For me it is up. For you down. They will tell down and then tell, ayo, sorry, sir. For you and me both it is up only. That is called trapping. Why? Suddenly in the flow, when I trap, they will fall to the trap. The moment I ask, everything I tell, in the mind, they will get the concept. Oh, opposite I will tell. The moment I ask for me up, for you down. Then they will tell, sorry, sir, for us also up only. Yes. Then I will tell them. If it is offline class or live class, in future, it may be little arrogant, but I tell, I am teaching. I can be, it is not arrogant, actually authority. In future, do not tell for me. I will take care of myself. You don't try to teach me or rectify me or train me in something. You came for learning. For you what? Sir, anti-clockwise. Keep quiet. For you what? Sir, clockwise. For you, sir, right. For you, left. That's all. For me, what? You never discuss. Of course, someone will tell, after the class, they may tell while going, yes, sir is so arrogant. It is not arrogant. Somebody will tell, it is not arrogant behavior. He is just giving idea that, or he is telling that we are learning. Whatever he tells you, whatever he tells you have to believe it and don't question the authority. Okay, leave it. For joke only I told. Now see, correctly. I wasted 5 minutes. Okay, you can enjoy. Now see. I will tell once for all. I will not repeat once again. So many times, see, in structural engineering, I will tell you one more thing. 1 minute. 1 minute. I will tell little concept required. I am not able to get it. Okay, something here. There is a beam bending this way. It is called sagging beam or hogging beam. I will tell them, show the neutral axis or axis. They will start scratching the head. Sir. Or maybe it is, this I can't bend actually. That fluently I can't bend that one. I will show something else. Okay. Okay, a beam. Okay. It's very weak. See. Bending this way. Okay, they will tell. Then I will tell, bending this way. Show the axis, neutral axis. Or it may be twisting here. See, twisting. When you go to strength of materials, a term called neutral axis or axis about which it is bending moment or twisting moment will come. Very powerful. In a bending, it is called neutral axis. Doubt comes. Then I will clarify. What I am telling now, I clarify it. So therefore, I will tell you now only. Later in strength of materials, I will tell you long back, engineering mechanics told, go back. See, correctly now. Don't worry, rotation this way. Show me the axis. Some will tell, sir, this way. No, see there. Axis means throughout the rotation, it should remain at a constant distance. Anything, see, I will show my hand. See my hand. I am rotating the hand. Only see, this hand means what? Only this wrist portion. Only this portion. See. Don't see other things. Throughout rotation, it should remain at constant distance. From which axis? Sometimes people will start thinking, then they will tell, sir, here, come here and tell me, show me. Then someone will come and tell, show it here, see. I will give him a tube light. Okay. Use the tube light as axis. He will put here. Hey, I should not hit it. Got it, sir. See. See now. Here, distance. See here, distance. So, throughout, I will put here now. See, this is a little too long. I will make it a little shorter. So that, okay, concept should be clear. Okay, I will hold something here. Okay, this will do. Okay. See here now. Throughout my rotation, wherever I stop, see, constant distance. So, if the rotation is this way, this is the axis. See, your vehicle wheels are going this way means it is rotating about the axle here, this one. Now see, okay, this over now, I will turn here. Now student will tell, sir, got it, sir. See here. See. Okay, then I will tell. Now, sir, here. Yes, very good. See, this way. Therefore, remember, axis of rotation means an axis such a way you have defined so that each and every point in the body should remain at a constant distance from that axis throughout the rotation. Okay. Now, there's an easy method is there. Once I tell the easy method, next time onward student will give answer within no time. I will tell, if you go to an interview, if they show axis, you give so fast answer. The person who is interviewing should get a shock. What, this person is so much concept based. Okay. See, I use left hand. Okay. See, move the hand, then see. You move the hand, See the circle there through center, put this way. Ah, yes. See now, see here. Axis. Where is the axis? Sir, here. Ah, yes, very good. Tell the axis now. Sir, here. Ah, yes. See. See here. Now see. Now see. So, see, lastly I will tell you, I look here. See. This way is the axis. That's all. That is axis of rotation. Of course, I believe in simple language. I do not want to go to complications. So that is the axis. So when you tell moment, remember basically moment is always about an axis. Okay, now I will lastly today's class I will close because feeling little not tired actually, little late. Okay, I first thought today I will not upload any class. All these days from past around 10 days daily I am uploading. So I thought no, let me start moment today. Give some basic idea for them for you. Next class I will start expression for how to find moment, examples, full numerical part will come and technical part will come. So now lastly what I will do is I will clarify the doubt about instead of considering or writing moment about an axis, in structural engineering 99% for solving problem you write moment about a point. Is it correct or not? It is correct. I will tell you why correct. Okay, I will tell you why. Now, clarification. Consider a coplanar force system. See, randomly, one force here, one force here, one force here, one force here, randomly, any forces. Coplanar force system in general, concurrent you don't require because for concurrent force system, you don't take consider moment. Leave it. Actually, concurrent also is there. This is coplanar but a parallel force system. It can be like or unlike, will come later. They are parallel to each other. It can be this way also. See, even this also is called parallel only, or even this also is called parallel. Leave it. System. See, this is remember coplanar force system in general. Like you should write after the class. Line of action of all the forces lie in one plane. Parallel force system, which is coplanar. Line of action of all the forces lie in one plane. See, and write that plane is here, here, here. That plane is plane of the board, plane of the board, right? He is showing it now. See, this plane, this plane. Repeat it. Go through the class again and again. Okay, now see moment about, consider any point, see any point in the plane. See, any point, consider, okay. Consider any point in the plane, say O, somewhere here. See, somewhere here, any point in the plane, O. Here also, consider any point in the plane, say here, O. Now see, first what you do is, you want moment. I will explain in the next class how moment is calculated. First you mark the axis. How? Through the point O, you consider an axis perpendicular to the plane. See here, this one. Then see. See, now this is, see, for all these forces, moment will come how? See, it can come this way, see, for example. Or see here. That's all we will worry later. How to decide clockwise, anti-clockwise, I'll tell you later. See here. It is clockwise. Anti-clockwise. See here. This force. Clockwise. See this force. anti-clockwise. So the moment will be either clockwise or anti-clockwise, and your moment you can show in the plane right here. The moment we can show in the plane. We can show in the plane. See here, I use my hand. Clockwise, anti-clockwise in the plane. So you already know it. If moment is this way, axis is, see. So therefore, you use the pen, consider an axis passing to that point, but perpendicular to the plane. See here, this one, or here, this one. So all these moments are about this axis. See. So both I written here, both are, remember, I am considering coplanar. Once again I am telling, not for 3D. I am considering coplanar, very important. So as long as you consider coplanar force system, remember, not space system or 3D force system. I will tell you about 3D little later. Coplanar force system, both these are about an axis perpendicular to the plane, see, to the plane, but passing to the point O. Therefore, instead of wasting time, writing every time moment about an axis, see what I am telling now, you write now. What I am telling you write. Instead of only for coplanar force system, I am repeating, instead of wasting time, every time writing moment of the force about an axis passing through that point, and the axis is perpendicular to the plane, it will waste a lot of time required. You can use the word simply moment about O. Therefore, if you use the statement moment about O right here, it means, I am dictating now, you should write. Those who want should write. In future, for a coplanar force system, if I tell moment about O or about any point A or B or C or D, whatever I call, it means moment of the force about an axis passing to that point, but the axis is perpendicular to the plane. Now, usually, see, this is called x-axis, positive x. This is called y. This is called z. This one z. I can't show it here. I'll show this way. You know it. If I show this way means what? See, actually it is this way, z. So, all this moment here is actually moment about, if I call the point O, moment about what? About OZ, z-axis. That's why when you put equilibrium equation later for coplanar, you write sigma fx equal to 0, sigma fy equal to 0, and sigma m0. Usually for coplanar, you write sigma m about any point equal to 0. Technically, it is not. Forces are along x and y. Moment is about z. It is called sigma mz equal to 0. Remember, forces are in x and y, but moment is about z. But we won't write sigma mz 0. You tell moment of the force about, you will use about any point which lies in the plane. So when you tell moment about any point which lies in the plane, it actually means moment about an axis passing through that point and perpendicular to the plane. Write everything here, I will dictate. Those who are serious should write. Now remember, this is as per STAAD.Pro. If you go to STAAD.Pro software, see there it is 3-dimensional. There is no question of moment about a point. It is called mx, my, mz. Moment, they are always about axis considered. Moment about xx, moment about yy, moment about zz. because it is not coplanar. But in E-TAPSOL, this is called X, this is called Z, this is called Y. What we call MZ here in E-TAP becomes MY. You worry later. But in general, usually, what people will tell? X, Y, Z. So, all these moments are about Z axis. Now, I will conclude now. See, in future, for you, I am writing here I am writing statement, dictating, but I should dictate in red color. In future, as long as our force system is coplanar, very important, as long as our force system is coplanar, it can be either concurrent or general coplanar or parallel force system, but coplanar, then instead of wasting time writing moment about an axis perpendicular to the plane passing through a particular point in the plane, we can simply write moment about that point. So, instead of using the word moment about axis for coplanar force system, you can tell moment about a point. Last I will tell, now onwards, if I write moment about A for a coplanar force system, if I tell, I am concluding now, right here, in future, if he tells means if I tell, moment about A means moment about an axis passing to the point A perpendicular to the plane. If I tell moment about B, moment about an axis passing through that point B and axis is perpendicular to the plane. So we won't waste time. Moment about an axis passing to the point A perpendicular to the plane. What you write? Moment about A. So in future, even if I write moment about A or any point, it's actually about an axis passing to that point perpendicular to the plane. I'm stopping now. In future, suppose someone will tell, sir, in your class you told sigma m about A0, sir, but some textbook they put sigma mz0. Class part 1, class 18, why you have not gone through? You can't suddenly come to a class and tell this is not clear. Go and see there. Those dedicated people who study, they will understand everything. So, I am concluding now. Next class, I am going for how to see. This is today's class is fully concept based, some lecture type. I already told earlier, I am not good in giving speech. So, but I told you the simple way. Technically talking means I got more fluency. Like if I want moment, I will tell, see, 100 into 8 like that. Fluency more. This general talking, it's like giving a speech, but it's a technical speech. So I don't have to think. So I told in sometimes humorous way also. Enjoy the class. Go through repeatedly and conclude finally coplanar force system. If you write moment about a point in future, I will write that way only. It actually means about an axis passing to that point perpendicular to the plane. Okay, thank you. We will meet next class where I will give how to, that is next class is more than important than today's class. Today's class is concept. Next class is principle of, that is how to find moment about of a force, about any, see, I am changing now, about any point, how to decide clockwise, anti-clockwise, when difficulty comes, inclined force is there, what to do, that all I will explain in the coming classes. I will see that everything you understand perfectly. Okay, thank you.